Okay, so our next topic is about logarithm. I go. So logarithm functions are closely related to exponential functions, and it is a relationship that we will exploit in our description of some of their key properties. So we have something like log with a subscript of a and b. I go. That is how we read this. It's log ba, not log ab. I go. So log b, so log b to the base a. I go. So log, this is the exponent. This is the base. So this is how we read it. Log ba. That's what's written in the log b base a. Now we have principles of logarithm. So the principles of logarithm, we have rule 1. Log a into exponent. So log exponent xy base a. Now, when something is in this form, meaning it's multiplication. If it's multiplication, we add. I will. So log x base a. Since it's multiplying, we add. So plus log y base a. Now rule 2. If it's divided, we subtract. So log x base a minus log y base a. Rule 3. If we have log x base a with another exponent, we move the exponent and bring it in front of the log. That's what is being indicated here. So it becomes n log x base a. Okay, note behind. Okay, log x base a exponent 2 means that logarithm of x squared and not the square of log x base a, which is written as this. Take note. Okay, we also have what we call the natural logarithm. Any logarithm to the base e is referred to as natural logarithm or e. These are the principles for natural logarithm as well. In e is equal to 1. I go. Now, in n base x, with this 2, we move the n and bring it in front of the e. Sorry, the e. To become n in what? Is what? X. Now, if it's the same understanding, if it's addition, it becomes multiplication. If it's subtraction, it becomes division. Now, in x is equal to y, x is equal to e exponent y. So these are basically the understanding we have based on logarithm and what? Natural logarithm. So these are the principles involved when we are dealing with logarithm. And these ones are also the principles involved when you are dealing with natural logarithm. So we pick questions on both, then we solve. We are starting with questions on logarithm. So the first question, if log 3 base x is equal to e, find an expression for log 27 base x. So question 1. So let me do a solution. Question 1. We're given log 3 base x is equal to e, and we're asked to find for this, for log 27 base x. So what we do is, we are going to find two numbers. Then when we multiply, we are going to get what? 27. So the understanding is we now have log x into brackets. Sorry, there's log 27 base x. So it comes 3 times 9. 3 times 9 is going to give us what? 27. I do. So now, based on the principles of logarithm, if it's multiplication, it becomes what? Addition. So we now have log 3 base x plus log 9 base x. I go. Now, we're giving log 3 base x as a. So meaning that the whole of this log 3 base x is going towards a. Now we have log 9 base x. This log 9 base x can still what? Simplify. So we now have log 3 base x plus log. Now this can give us 3 squared. With 3 squared can give us 9. 3 times 3 was 9. So we now have, let me do it here. We now have log 3 base x plus log 3 square base x. Now based on the principle of logarithm, whenever an exponent is having another exponent, we move this exponent and bring it in front of the log. So it becomes log 3 base x plus 2 log 3 base x. That's how we do it. So now they have the same what? Bases. So log 3 base x was given as what? A. So the whole of this is what? A. Plus we have 2 here. Log 3 base x was still given as what? A. So we have A. Now A plus 2A becomes what? 3A. Since any variable still known as 1. So 1 plus 2 becomes what? 3. So 3A. So this is the first part of the question, question 1. So moving on to question 2. So question 2. We're given log 2 base x is equal to A. Log 3 base x is equal to B. And we're given this function. Log 12 base x. Okay. So now we'll find two numbers and when we multiply, we're going to get 12. Someone can get that okay. 2 6 is giving us what? 12. But now we can have log 2 base x times becomes plus log 6 base what? X. We are supposed to simplify the 6 as well. Either. Now there is no number that when you square it, you will be able to get what? Log 3 base x. 2 exponent 3 is giving us what? Let me see. 2 exponent 3. We are getting 8, which is wrong. We want 6. Let me see. 3 square. 3 square. It's giving us 9. Which is wrong. It's not giving us 6. So meaning that we are supposed to change what? This 2 again. Meaning that 2 and 6 cannot work for what? This equation. So we change it. Let's try. Let me see. 3, 4, 12. So now we have log 3 base x. Sorry, let me start it in this form. This. 3, 4, 12. So log 3 times 4 is giving us 12. Now let's expand this. We now have log 3 base x plus x times 2 plus log 4 base x. Okay, we're giving log 3 base x expression as b. So this is b. Now we can still simplify this because we want what? An expression like log 2 base x. And we have log 4 base x, so you are supposed to simplify it to get this equation. So now we have log 2 square base x. Now we are going to bring this 2 in front of the log. So we now have b plus 2 log 2x. So we now have b plus 2 log 2 base x. So we have b. Log 2 base x was given as what? A. So we have our 2a. So the whole of this is what? A. So the final answer is what? 2a plus what? B. So that's how we do it. First, we need to check 2 times 6, which is giving us 12, was not getting what? We were not getting log 2 base x in it. So we are supposed to change the numbers. So now we are using 3 times 4, which is 12. Now log 3 base x, it's already here. We can get the b. Now, log 4 base x, we can simplify the 4, getting log what? 2 base what? So log 2 explains 2 base what? X. I go. So we simplifying this, we bring the 2 in. We now have 2 log 2 base x. Now, we are giving log 2 in the question. That's it. Log 2 base x as what? A. So we represent the whole of log 2 base x as a. So there's the a here. Now the 2, we bring back our 2. We can't add that because this is b, this is an a. So you have 2a plus b or b plus 2a. So we are done with question 2. We move on to question 3. So question 3. Question 3 we're asked to find x using this equation in x plus 4 squared is equal to 3. Okay, once we see in, meaning that we are referring to where? natural logarithm. I go. So let's solve this. We now have, sorry for my marker here. Let me change it. So now we now have in to bracket x plus 4 squared. We have this. Okay, based on the understanding of logarithm and also what natural logarithm, with this 2, we are supposed to bring it in front of what? The in. So now have 2 in x plus 4 is equal to 3. So what we do is we rewrite it back. We now have 2 in x plus 4 is equal to 3. We divide both sides by 2. We now have 2. There, 2. It moves out. Now, 3 divided by 2, what are we getting? 1.5. So now have in x plus 4 is equal to 1.5. We want x, but there is an in here. So for x to be able to eliminate this in, we write x plus 4. Since we want to eliminate the in, we bring e here to the power this number 1.5. So now have x plus 4 is equal to e. So e exponent 1.5. So let me check it out. 1.5. What are we getting? 4.48. So we maintain x. You have 4.48. There's 4 here. Remove it. Minus 4. So x is equal to 4.48 minus 4. You have 0.48. So this becomes what? Our x. So we are done with question 3 as well. So we move on to question 4. So we have question 4 here. We were asked to solve for x. We were given e exponent 5x is equal to 0.34. So what we do here is we have e raised to the power negative 5x is equal to 0.34. Now we are finding for x. Since we have e here, we already have e here. We only write negative 5x based on natural logarithm. If this side is having an e and we are finding for x, we write it back negative 5x. But since this side was an e, we bring e here into bracket the number there 0.34. It's vice versa of the previous one we saw. If there is an e here, you bring an e here, exponent the number there. But if there is an e here and you are finding for the x, you write only the number negative 5x. Then we bring an e to the number I go. So e into bracket 0.34. So you have negative 5x is equal to 0.34. You have negative 1.078. So negative 5x is equal to negative 1.078. We divide both sides by the coefficient of x, which is negative 5. Negative 5. So let's see what we get. X is equal to negative 1.078 divided by negative 5. We have 0.2156, which is approximately, let's say 0.212. 0.212, okay. So this is how we solve the question 4. So we move on to question 5. I hope you guys are following. If there is an e here, we only write a number here and bring an e here into bracket the number. If there is an e at that side, we write only the figure negative 5x and bring an e here, but to the exponent of what? The number. Okay. I'm moving on to question 5. So question 5, we have 4e 2x is equal to 798. Okay, now I'm finding for x, but before that there is a 4 here. So I'm going to divide both sides by the coefficient of e exponent 2x. So I do this way, 4, this side 4 moves out, and now I have e 2x is equal to this. So 798 divided by 4. What am I getting? 199.5. Now I'm finding for what? X. But there's an e here, so I only write the 2x. Since there's an e, I bring in here into bracket the number 199.5. Okay, so now let me continue here. So I have 2x is equal to in of this number, in 199.5. What am I getting? 5.2958. I want x, so I divide both sides by the coefficient of x, which is 2. So this side 2, this side 2. So x is equal to 5.2985. 5.2985 divided by 2. What am I getting? 2.649, which is approximately 2.65. Okay, so we are done with the question 5. So we move on to question 6. So question 6, we're also given, okay, question 6 was what we just saw. So we moved on to question 7. So question 7, we have question 7, we have 5 in 4x is equal to 9.84. We want x, but what do? We already have a 5 here. You can't just begin by raising an e to the exponent less. We need to first divide both sides by the coefficient of in into bracket 4x. So 5. This side to 5. Then the 5 moves out. We now have e into bracket 4x. So 9.84 divided by 5. We have 1.968. Since there's an in here, we are looking for the x. We will write the 4x back. But because of the in here, we are going to bring an e here. But whenever there's an e, it's to the exponent of the number there. So e exponent 1.968. So we have 4x is equal to e exponent 1.968. What am I getting? Getting 7.1563. I want x. I divide both sides by the coefficient of x, which is 4. This side to 4. So x is equal to 7.1563 divided by 4. What am I getting? 1.789. So the question 7, so this is what we are getting for the value of what? X. So the logarithm, these are basically the basis in the understanding you are supposed to have whenever you are given a logarithm question. We are going to solve one more last question, which is a little bit tricky on logarithm. Then we say bye to logarithm for now. Okay. So with the question 8, that's our last question on logarithm. So question 8, the computing equipment belonging to a company is valued at being Ghana cedis. Each year, R%, which is the rate of the value, is written off depreciation. The value of the equipment at the end of 3 years is given by the expression Vt is equal to V into bracket 1 minus R over 100, all over, so brackets close, exponent t. Make t the subject of this formula, which is the A. B. Find t when V is 45,000. Vt is 34,848 and R is 12%. So first we should make, so with the A, let's make t the subject. So we have Vt is equal to V. We have 1 minus R over 100 over t. Okay, when you are given something like this, you need to be very careful and pay critical attention to this. When you are given something like this, and you are being asked to make T the subject, they said we should make T what? The subject. So what we'll do here is, okay, if we are given this equation, that's how we do it. We have a vein here. I go. We are supposed to eliminate this vein so that we will be left with only this. So we have, so we divide, so we have Vt is equal to vein. We have 1 minus r over 100. We have the t here, so we divide by the vein. We divide this side too by the vein. Now the v moves out. We now have Vt all over vein. Thus, then we have 1 minus r over 100. Then we have the t here. So let me restart. Vt is equal to vein into brackets 1 minus r over 100 all over. The exponent is t. What we do is we want to get rid of the vein so that we'll be left with only this in the bracket. So we divide both sides by what? The vein. So vein. The vein moves out. We now have this Vt over vein is equal to 1 minus r over 100 exponent t. Now when you get to this point, this side is raised to the exponent t. And this is what we are looking for. So how do we get this t? This is where we apply the understanding of what? Natural logarithm. So we are going to take in of what? Each side. So applying the idea of natural logarithm. So we take in of what? Each side. So we now have in into brackets Vt over vein is equal to in into brackets 1 minus r over 100 t. So what we do next is, let me rewrite it so that you guys get understanding. So Vt over vein is equal to in into bracket 1 minus r over 100. We have our t here. So what we do is, we now have in here, we also have in here. We use the understanding of when we have, let's say, log ax to another exponent. So log x is a, and the x is to another exponent. We move the 2 and bring it in front of the log. We are going to use that same understanding here. So now we have t here, so we are going to bring the t in front of the in. So we now have t in into bracket 1 minus r over 100. We have in into bracket Vt over vein. Now what are we looking for? We are looking for what? T. So we divide both sides by the coefficient of what? T. So we now have t is in by 1 minus r over 100. That's equal to, we have in here, we have Vt over what? Vein. So we divide both sides by in into bracket 1 minus r over 100. In into bracket 1 minus r over 100. This moves out. We now have t is equal to, this moves out. Now t is equal to in to bracket Vt over vein all over in into bracket 1 minus r over 100. So this is what we were asked based on question A. Make t the subject of this formula. So this is t. So we now have t here. T is equal to in to bracket Vt over vein all over in into bracket 1 minus r over 100. So with the B part, find t when vein is 45,000, Vt is 34,848, and r is 12%. So we are going to pick this our final equation for the t and substitute the values into this. Then we get what? The t. So with the B part, find t when vein is equal to 45,000, V is 34,848 and R is 12%. So we now have our T to the test. So we are just going to substitute the values into this, then we get a T, that's all. So T is equal to, we have E to bracket VT over 3 all over E to bracket 1 minus R over 100. When VT is equal to 34848. V is equal to 45,000 and R is equal to 12%. So we have T is equal to, we have the E here. V is 34848. V is 45,000. You have another E. 1 minus R is 12%, 12 over 100. So now we have T is equal to, let's do the top one first. E into bracket 34848 divided by 45123. 3 zeros, we have negative 0.25. Let's do the down part. E into bracket 1 minus 12 divided by 100. You have negative 0.12. So T is equal to negative 0.25 divided by negative 0.12. You have 2. Thus. So the B part, that's how we do it. So we have the B to what? Find T when V is 45,000, B to 34,848 and R is 12%. So T is what? 2. So there's how it is. So there's the, let me see, the combined type of logarithm whereby you make change of subjects. Before you will be asked to find for T by substituting in what? The values. Yeah. So that's all our, when we talk about logarithm. Thank you guys for watching my video. Please make sure you subscribe, share the videos to your friends as well. Let others also benefit from the videos as well. Thank you all. Please remember to tell a tithe so